So at the moment, an air conditioning unit is currently charging this vehicle?
At the moment, an air conditioning unit is currently charging this vehicle.
Wow.
Yeah. So to unlock an electric vehicle, press once, just like your fuel cap.
Okay.
And then you've got an alternating current and DC current.
Yeah, okay.
But obviously EVHACS is alternating current, so what you're doing is you're just opening your alternating current and you're just going to plug it in.
Straight in?
Straight in.
Okay.
That's it. So what happens now is the car communicates with the air conditioning unit or heat pump, EVHACS.
And this is doing something here, is that?
So that's telling you now that it's going blue. So if we look into the car can communicate with us and tell us the other way, sunglasses the way. The car will tell us then what it's actually doing. So it is charging at 32 amps.
Okay.
Which is the max the car can charge at.
Okay. On
a single phase. And then my watch is beeping. So that's the watch telling me that what time it'll be charged at. So it'll be charged at 17:25. So it's now doing 7 kilowatts of charge.
So at the moment, an air conditioning unit is currently charging this vehicle?
At the moment, an air conditioning unit is currently charging this vehicle.
Wow.
Yeah. So this particular air conditioning unit, which is hidden inside the building, was one of the world's first, about 2.5-3 years ago.
Okay.
So well tested, has the latest technology on it, but every day it's been working charging cars.
Wow. Okay. And what's the size of this charger?
So this charger will be a 7.4 kilowatt charger, effectively 32 amp single phase.
Wow. Okay.
Yeah.
And in relation to what is currently out there, if you were to use or have an EV charger installed in your house, what is the average size?
So domestically, single phase, most EVs will not take more than 7.4 kilowatts, 32 amps.
So if you've got a heat pump or if you have an air conditioning unit, in your home, or you're thinking of having one fitted, the charging connection in this
will be 7.4 kilowatts.
Will be the most you actually can have and require.
Yeah.
So the need for a second external EV charger, you don't actually need one because the technology is all in the unit.
It's all in the heat pump or air conditioning unit. It's all done. So it will charge your car at the same rate as any other charger that's out there.
Okay. Gotcha.
In a single phase environment, and only in a 3-phase environment does that start to change to 11 kilowatts or 22 kilowatts alternating current. So, and then in DC can charge up to I think 150 kilowatts.
So if you've got a commercial building and you need to replace say 10 split units and they're at the side of the building or the low level, we can then you can replace these with this system already in place. So it's almost like you're doing a replacement like as you need. But you're actually adding EV chargers to your commercial building. Yeah. I don't want to say free of charge, but you're not having to procure out.
The pun.
Yeah. You're free of charge. You're actually doing two for the price of one-ish.
Yeah, for sure. Yeah, like if you were to go and then install chargers, the other problem you have is then you've got to look at the MIC in the building, which is the total power in the building. But as we know, as air conditioning people, that air conditioners don't always run at their full capacity.
Yep.
So when they're not run, they'll bring the temperature down or bring it up in minus 35 or minus 10 plus 35, whatever we say that.
Yep.
So we always have additional power left, and all we're doing is increasing that a little bit back to the board, and then using that power right hopefully across the globe, where we have this huge redundant HVAC power. It's available, and we're losing it to do electric vehicles.
So one of the questions that I'd probably ask is, if I've got 5 split units in my, let's call it government building, and they're being used through the day, and I've got 5 cars being plugged into them units, is there a risk of overcurrent?
No.
Is this system smart enough to understand, give me more power to the car because the air conditioning unit is consuming less? Is there something in place in that?
That's exactly what it does. So there's a thing called the Elliott, which is an energy device, and it monitors the power to the building or that circuit, if it's an individual circuit, and then it looks at how much power the car is asking for and how much power the air conditioning wants, and it balances all three. So you'll never have a scenario where the building will fall over due to the HVAC and the car's charging now.
So there's a lot of peak demand for the HVAC units in your commercial building. You'll find that during them peak times, the cars will receive less electricity because the building needs it. But when demand is met and the units slow down, your car chargers are getting, the higher amperage or the higher kilowatt out of the chargers.
Like, you're limited to what the building has. You're always going to be limited to what the building has, so we have to take that into account. So what we do is, though, if it's, let's say it's a 25 amp breaker or 20 amp breaker, we go to a 40 amp breaker.
Okay.
So generally there's nearly always enough to charge the car, but then we're also monitoring the building or that circuit. So if that circuit is starting to ramp up, we take the car down in terms of power. But we can also reduce the power to the heat pump or the air conditioning if we want it as well.
So that answers my next question. My next question was, if I've got an air conditioning unit on a 32 amp breaker, but also on that circuit I've got, I don't know, an outdoor light, that and there's or a socket or something, your device will monitor that and say, well, actually I'm monitoring the supply, I'm working to the supply, not just the air conditioning unit.
Correct. So generally with all EVs and in terms of air conditioners, they're supposed to be on their own dedicated supply back to the board.
Yes.
But you're basically monitoring what's coming into that board. And if it's over 3 phase, you're monitoring each phase. If it's a single phase, you're monitoring that. So a house in Ireland is 63 amps, so you're always looking to 63 amps.
Yeah.
And then this building is 63 amp per phase over 3 phases. So we monitor each phase.
Okay.
Which is great. So you can't overload any of the phases basically either. So you're always going to be limited to what the building has.
Of course. Yeah. But then you're applying diversity where peak load isn't needed. You're getting diversity and you're giving power to the cars.
Correct. And in terms of designing the building, it means that going forward, knowing that the cars are now interlocked with the heating and cooling means you can account for it better at the design stage.
Understood. And then if you've got a hotel or a big commercial building with some really big air conditioning units, you can have bigger EV chargers?
Yeah, so the plan is we will go into VRF, which is the larger systems with more power. At the moment, we're just doing kind of small split, single phase, 3 phase and heat pumps, basically.
So this is probably more generic, common, commercial buildings have smaller units.
Like around here.
Bigger units have, even hotels have some split units.
For sure.
Everyone has a comms room.
Yeah. And then
if you have a comms room, you can have an EV car charger.
Correct.
It's as simple as that.
Yeah. And I say classrooms now, schools in Ireland are starting to do a bit of air to air, would you believe? They're doing heat pumps. Around here, you've got a lot of air conditioning. You've got air conditioning on the roof, and we just drop a cable down. Like, air conditioning is ubiquitous, and it's just going to get more. And in warm countries, where we just use split air conditioning for everything, it's a godsend, this product. Right. Although we're not warm here in Ireland because it's cold today. I'm just surprised it's not raining.
You can say that because you're from Ireland.
Yeah, I'm allowed to say that.
In relation to somebody that's watching thinking, is this just a cheap knockoff product that just bolts on and affects the life of the unit? Is there any intelligence to say that our product actually understands the unit? Is there any learning in there? Are you monitoring any points?
Yeah, so we're monitoring 74 data points within inside the air conditioning system. The team that we have is a multidisciplinary engineering team, software engineering, electronic engineering. Actually, the team we're doing safety devices for car chargers. That's where they came from originally. So we are working in unison with the heat pump or air conditioning unit, but we're agnostic, so it can go into any heat pump or air conditioning system. But there's been 3 years of development on this. It's been certified by an international standard, which is called SIQ, that can certify and look at standards for heat pumps and air conditioning systems, or heat pump and EV chargers. So it's been hit by lightning 3 times. There's all sorts of tests that are carried out.
Hit by lightning 3 times.
Hit by lightning 3 times. We'll show you later on what that CPCM, that charge point control module, looks like. It monitors temperature in the heat pump. If there was a problem with the compressor, it can step down its own temperature. It's always watching to see what goes on. It's tamper proof.
So it's looking at the parameters of the unit, and if it doesn't like the parameters of the unit, it'll almost adjust.
It'll throttle back or get out.
Understood.
So we're safe, because all EV charging is extremely safe because of the power that's coming through. And we're looking at the heat pump going, what if something goes wrong with that heat pump? What do we need to do to protect ourselves? So we're always monitoring that.
So installers, you can't blame this EV charger for your compressor or poor installation, because it protects the unit and it protects itself.
And we're even protecting the boards, additional protection on the PCB boards within the air conditioning system, so it could be a bit of a lost revenue there. No more boards will blow, because we decided we want to protect everything for ourselves.
So at the moment, is this product available in the UK? It's obviously available is it available in Ireland at the moment?
It is available in Ireland, yeah. So it is built on top of a Mitsubishi electric unit.
Platform, okay.
It's a platform, but it's sent to us, and we upgrade it then to have the charger built in, and it becomes an EVHACS system.
Okay.
It's available in Ireland, so the first customers had them. We've like a Londis with it. We have hotels. We've got our first gyms, all running off it. Offices, of course, and our first housing estate has them too. Heat pumps, EcoDans. We're aware EcoDans now, EVHACS systems, and we hope to be in the UK around July or August. There is an entry point. I can't say at the moment what that is.
It's coming then.
You'll be seeing us, in July or August in the UK.
So the next 5 years, where, you know, obviously it'd be amazing for everyone to adopt this. I can see that if anyone has an aging air conditioning unit on a commercial building, you'd be stupid not to have this put in, especially if somebody has an electric car. It's almost a no-brainer.
Well, it's cheaper. It's cheaper to put in when you're putting in your HVAC to put in a charger than it will be to do separately. And then obviously with the energy monitoring that's going on, you're getting free energy management effectively.
Okay.
So it's a much cheaper product than doing separately, and it will protect the grids into the future because it will marry the two biggest draws of power in the future, which is your heating and cooling in your cars.
Mm-hmm. Oh wow. Okay. And on a monetary basis, if I was a hotel owner and you know, I've got a company at the moment that I'm earning a bit of extra money in, 10p a kilowatt or something for somebody charging my EV. Is there scope that if I had this product in my hotel that, you know, there's a way of me generating income from that?
There is. So the way we've worked it is, so domestically we've obviously rolled out in heat pumps, which is fantastic. And there's a commercial product coming, which will be the first launch product in the UK, which will have a payment gateway on it. So for the first time ever, your air conditioning will pay for itself over time, because we'll obviously charge the car, but we'll use like a tap function to do it. So you'll come up behind your HVAC or near your HVAC, it'll be 25 metres away, but you'll see a remote socket. You'll just tap, plug in your car, you'll charge. And we share some of that revenue with the building owner.
Didn't think I'd ever hear the day that my air conditioning unit could potentially make me some money. That sounds nuts. It's usually, it costs me money.
It's usually sunk cost.
All the days of we're putting in an air conditioning unit to cool the office down, all they do is complain they're too cold now. Yeah. Well, actually, there is some form of you can actually generate some income from it. Yeah,
100%. Yeah. So like the way we look at it is over the life cycle, probably depending on the size of the charger, depending how often it charges, but less than kind of half the length of the life cycle will pay for itself. Like it comes somewhere between 5 and 7 years, we estimate. So like that's pretty impressive, depending on the size of the install, depending on a lot of factors, but somewhere between 5 and 7 years. So while there's a little bit extra to install it in terms of cost, and it's not a huge amount, it is sub €1,000 to do this on a cost basis on top of an air conditioning system. Sure, it'll pay for itself in no time.
Oh, wow.
Less than 5 to 7 years compared to somebody else. Yeah.
So in relation, if I wanted one of these installed in my office tomorrow, what is the route? How do I get one? How do I get my hand on one of these?
So it's a lot easier in Ireland at the moment.
Let's go back. Let's say it's November 2025. How can I get a hold of one of these?
So they will be distributed. Maybe we look at some good distributors in the UK.
Yeah.
But they will be distributed to the UK. The model in Ireland may not be the exact same model in the UK, but effectively where you can get a Mitsubishi Electric unit today, you'll be able to get an EVHACS unit tomorrow or in November. And
Fantastic.
The beauty about that is it'll start to roll out then across the UK.
Fantastic. And in relation to having that installed, the EV side, obviously with the UK, you have electrical regs and your electricians. It's a case of if I need to upgrade the supply for this EVHACS unit, I'm going to need an electrician to do that. So, I'm going to use my installers, my in-house installers, to install the AC unit. My electrician then just needs to do the electrical side and then sign that off. Does he need to test it? I know I've got a friend, Ashley, my big electrician guru. He's the man that'll say, oh, you need an independent supply, it needs to be tested. Is it the same process?
So, yeah, I mean, look, in Ireland, from an air conditioning heat pump perspective, we're not allowed to go straight into the board.
Correct.
So it does have to be an electrician, a registered electrician. They will run their tests on it the same as they always would. It's called an appliance. So the difference is it is an appliance. So where you would have to have two separate, obviously, cables going if you had a charger and a heat pump, it's one. So it's one appliance. So the standard is reflected to that appliance.
So when they test the circuit, they're testing the appliance. The EV charger and the air conditioning unit is classed as one appliance. It's one appliance.
It's one appliance.
That's pretty... Yeah. It seems a lot less paperwork in a really strange way, because instead of having two appliance tests, you're just doing one.
Yeah, I mean, look, it is that. It's obviously maybe going forward, the electricians might not get the same value in terms of, obviously, they're not getting two for one.
They get paid too much anyway.
But what does happen?
Way too much.
I'll let you say that.
Yeah.
But what we do is the cable will get bigger. So as I said to you before, if you have a 25 amp breaker on a single phase unit, it is going to go to a 40 amp breaker.
Which may mean we may need to increase the power of the cable to the condenser to meet
10
the
square.
amps. Okay.
Yeah, as we call it, I don't know if it's say in the UK, but we call it 10 square cable as opposed to maybe 6 square cable. And then we have a 40 amp or CBO at the board.
Yeah.
And that's really it. The electrician will, however, fit Elliott as well, and they'll put the CT clamps, they're basically current transformer clamps, on to measure the power coming into the building, and that's basically it. So really basic sort of stuff for them. And of course, EVHACS are there to support all the way. It has an app, it has an installer app, it has documentation, it has everything that's required, and the same level of documentation that we require for the heat pump we also have, so it carries through.
Fantastic. Amazing.
This is kind of like a remote socket. These aren't the final remote socket products. We're obviously in a test environment at the moment, so...
Let's say this is... Let's just say... Okay.
Yeah,
well, if you want to say it's a test, because that's obviously a generic box. I can see why you've...
Yeah, so these are just generic boxes that we've used. This is an air conditioning unit.
So was this one of your first prototypes?
Again, another prototype.
Fantastic.
So what we do is this was the first one we allowed outside of the buildings to have a look
at. That looks like 5 kilowatt to me, guys.
Yeah, I think it's around a 5 kilowatt.
It's a 50.
Yeah. So basically what happens is the charger's built into that. You plug in, so this car is obviously charged because we're green, so it's finished at this stage, it's charging process. It's a small battery anyway, to be honest, in the Leaf. I think it's only a 40 kilowatt battery, so it will charge pretty quickly. That's a single phase charge, 7 kilowatts. And again, that can be up to 25 metres, so I could raise that all the way up.
So my next question was, if I've got a unit on my roof and I don't want condensers on my wall, if I can run the cable, can I run the cable inside? For a riser cupboard?
I mean, it's a 6 square cable. As long as you follow the same rules of running a 6 square cable inside a building, you probably could.
So
generally they don't. For what we've seen so far is people are just pulling them straight down.
However, if
you could run it in conduit or something.
Okay, fine. If we run it in conduit,
if you want,
protecting it properly, we've got 25 metres out the box.
Yeah.
You know, most floors are 3 metres per floor, so if you could easily, by the looks of things, go up 4 stories.
4 stories, yeah.
With no issue at all. So if you've got 4 condensers on the roof that need replacing, you could potentially have 4 car charging points off your condensing units.
Correct, yeah, correct. And the beauty is as well, if you wanted additional charge points, we have them too. Because obviously if you build a charger to go inside an air conditioning system, that's to facilitate self-air, which is it's an inhospitable environment sometimes. You can have water, you can have heat, there's lots going on there, you can have flammability.
Yeah.
So we've had to design a system that sits inside. You cannot just take a charger and put a charger into an air conditioner. Actually, if what keeps me awake at night, that would keep me awake at night. Somebody thinking you can just put a charger straight into an air conditioning system, because after 2.5 years of testing and development, we know what we have to do, and we've set the standard. So we are safe, and safety is hugely important to us. We're going to continue to do that. So yeah, from our side.
Amazing.
As a lot of us in the company have EVs, we wanted to keep the app as simple as possible. So really all you want to know is my car charging? If it's not charging, why is it not charging? So as soon as you log in, you have the status bar up at the top. So it shows you the current status. So this app is the login for the charger outside.
Okay.
Jeff's car plugged in.
Okay.
Connected to that air conditioner right there by the shutter.
Okay.
And that is connected to this comms unit here. This
okay, and that's the Elliott model. So we've got the Elliott model just around here, Ben. Yeah. So that is the comms unit.
So the green flashing just shows that it's connected to Wi-Fi right now.
Okay.
So the Elliott takes care of all the energy load balancing. So it balances the power between the EV charger, the air conditioner and the rest of the building. And even if you're offline, this will still take care of that load balancing for you. So the end user doesn't have to worry about the breakers tripping or anything like that, because Elliott is doing that all the time.
Fine. Okay.
So the reason it's connected to Wi-Fi is so you can control your charger with the app, set up smart features like scheduling, add users, give more permissions, that sort of thing.
Okay.
Alright, so I'll just go quickly through it. So this shows the current status. So down here, you can set a schedule. Because this is a commercial building, we have it set from 8 to 6 because we don't want people at night time coming in and stealing our power.
Okay, that's quite reasonable.
Yeah, so at home, like we all have these units at home, so at home we'd have it set for night rate electricity, so you go home, you plug in the car, then you don't have to worry about...
So it could almost be, you guys probably would, and you probably work really, really hard, you're probably here till 10 o'clock at night, so you'd set your you probably set your home charger at 10 p.m. to maybe 6 a.m. And then obviously if you want, and then at 6 a.m. if you're leaving the house, no one can pinch your electricity during the day.
Yeah, exactly.
Gotcha.
Yeah,
okay,
exactly.
Nice.
And as well, like, it's convenient. So you get home from work, you plug it in. You don't have to worry about going back out and making sure plugging it in again when the cheaper rates of electricity come online. So this is convenience and expense. Here you can set the power level. So this is a 7.4 kilowatt charger. You can change this yourself, although there is no need to change it because Elliott is taking care of the power level all the time. This is a regulation for EVSE charging. You have to have a way to manually do this. So that's why that is there. The priority switch. So this, right now the heat pump has priority. So you can switch this to the car. So if you needed your car to be full quicker, you'd set it to the car so that then the heat pump, the power to the heat pump would step down. So you shouldn't notice any change in comfort levels inside the house. It might be just that the hot water cycle takes a little longer to run.
I see.
Things like that. So you shouldn't notice any difference. So for this demo, we'll flick it over to the heat pump has priority. And we'll go through the demo and then you'll see that in action.
I know at the minute the unit is run off, is feeding this room, is that right?
Yeah, that's
so
the indoor unit.
To me it seems like, I thought it was a 10 kilowatt, it is a 10 kilowatt. It's obviously reached set point in here, or almost. Is there any way of me seeing how much, because I can see the 7.4, what does that mean in the top right hand corner of the screen?
Oh, that's just the setting. So
that is the setting.
But if you click here, we have the usage data. So this updates every 10 seconds from Elliot sending stats to the cloud every 10 seconds, and then we represent them back to the user in the app. So we can hover over heat pump.
Wow, that's amazing. So is this currently?
Yeah, at this in this
moment
10
in time
period, it's 1.62 amps the heat pump, and the EV is currently pulling 29.82 amps.
Wow.
So we have
talk about load sharing or splitting.
Yeah,
like,
exactly. Yeah.
Oh wow, that's amazing.
There's another CT clamp in this. I'll let Stephen do this because he's the electronic engineer.
Okay.
Okay, so we have two forms of load balancing in this setup. One of them is on the cable that's supplying the outdoor unit.
Okay.
Right. So it obviously supplies the power to the air conditioning in this case, and also the charger.
Okay.
Right? So we have told in the configuration, we've told Elliot what that current is, and we will balance to that current. So if the outdoor unit has ramped up for whatever reason, initial start, or maybe it's gone into defrost or whatever, it'll ramp down the car while it's doing that, and then it'll ramp the car back up.
When it's out of defrost. Okay.
Defrost. So you don't have to worry about an overload on that cable, which means you can minimize that cable, you can utilize your copper as good as possible.
Fine,
right?
okay.
Then the other load balancing we have is on the whole house. Right? So likewise, you have a set amount of power that you can get from your DNO, and we just make sure that we don't exceed that.
Okay.
Well, within the scope of our control, which is the full charging of the EV. Right?
So I'm just looking at this here. What's this? Is this building max supply? What is that?
So the building maximum supply, in this case, we have got 63 amps available.
To this building?
Yes.
Okay.
Now, in here, we're actually just on one phase.
Okay.
Right? So, but this is 63 amps would be a typical supply to a home.
Okay.
A single phase would be a 16 kilowatts.
Okay.
Right. So that's what we have here. So we kind of use this setup here to simulate kind of a typical house situation. So, you know, in order to do that, we also want to be able to increase loads in the building. So we have a way of simulating a load without actually having to turn on a load of kettles and
I see.
Yeah.
Okay.
and immersions and all the rest.
We tried it that way.
So
how would you do that?
So we basically
not the big red machine.
Yeah.
Or the small red machine.
All we're doing is we're putting current through the clamp that measures the building, but we're doing it at low voltage. So it's the same current, but it's at low voltage, so it uses way less power. So we can simulate it here. It's actually an old microwave transformer. But anyway, so I can I'll turn this up so that that's like somebody's turned on their kettle. Now it will take.
So now we should see the home segment appear in green here on the app.
So the home,
is the building, like we call it home here because we use this for testing the domestic app.
So someone's using the microwave.
Yeah. Obviously everything has already happened, it's just we don't send the data that often.
This should be quicker than that.
There we go.
Okay.
Wow.
Right, so that's maybe a kettle after turning on, right? So you can see up here that this line here is the maximum the building would
so it's like the overload
be allowed to have. So if I go again, I'll just push it right up.
Can we turn on the electric shower?
I can do electric shower.
Well, electric shower, or electric oven, I suppose, isn't it? They're the big two.
Yeah.
Overload.
Okay, so we've gone
Wow,
into
you've caused a problem
overload.
here. So what does that happen? What happens now?
So it's probably already happened, right? But we'll have turned the car down.
So the EV
So the-
should go down now.
Okay.
What
So the breaker hasn't tripped. I've not heard anything trip
no.
Yeah.
because the clever smart device is now gone too much, and then it will stop producing electricity to the car.
Yeah, it'll reduce. As I said, there is a delay between what we see and what actually happens, but you can see that it's rolled it back,
So now it's at 23 amps, the car.
and we're at our
Wow.
63 amp limit.
Okay.
So we're still charging the car, we're still using the heat pump, and the shower is still on, the oven is still on. And charging a car usually happens over a long period of time, so it's not a big effect if this load balancing is happening for 5 or 10 minutes.
Amazing. This is really cool.
Yeah, so that's the load balancing. So that's a major feature of the product, really, for domestic and commercial.
It's a necessary feature in
Yeah.
today's world.
Climate, yeah. So if you're a skeptic like I was, where we haven't got enough power to upgrade for all these electric cars, this keeps people like me quiet, because we say that when you aren't using your air conditioning or your heat pumps, you could actually be charging your cars, because as we know, our super smart efficient air conditioning units can vary in speed. If we were talking about 20 years ago, when we were talking fixed speed compressors, this wouldn't work. But we're not. We're in the age of efficiency, so the more efficient the units get, the better this becomes.
Yep.
Amazing. That's a wrap. Air conditioning, heat pumps, car chargers, it works, and it'll make you hit your net zero goals without having to have a massive, massive power upgrade. If you want to find out more, Google EVHACS.com and you will find them. Right, that's us done in Dublin, Ireland. Like and subscribe, stay tuned, and you'll see us in the next video.